So yeah, well, thank you very much all for coming along today, and so welcome to the training session on using the MDENet education platform for teaching MDE. And today we'll be looking at actually using the education platform. So we'll look at how to set the platform up so you can use it locally, and also create an activity for the platform itself, and for using the platform for teaching MDE for students. So, and finally, we might touch on integrations if there's some time at the end. I'm not sure if anyone has tried out the platform yet, or got it working, or that's good. And I'm not sure if anyone's following along, then let me know and we can try and keep up. So we'll first look at setting up the platform. And so the way to get started, so there's a couple of useful links here, which is Education Platform Wiki and Education Platform Docker. And so they're the main resources to get started. So in the Education Platform Wikipedia page or wiki page, you'll find some general documentation for starting to use the platform, and it's a good reference guide for after the session. So it covers adding a tool and setting up the platform, etc. So what I'll be following it through is setting up the platform in these steps here, which we'll run through. Additionally, there's more detailed documentation actually running the platform in the other link, which is also within this page here. And this is the main Docker repository page that contains the platform Dockerization. And so to get started, you'll need to have Git and Docker installed. But they're quite common tools. They should already have, you might likely to have them already set up. Inside there are some like pre-configuration steps that it says inside that in the wiki page for configuration for Mac and Windows, because Docker runs in a virtualized environment there, so they need to have more memory configured for them, but it's detailed in that part. So if we go to actually check out the file, so just have some like location on this local computer, and so I'll just check out the repository. Check out the repository, that Docker repository there, and the contents of the repository there. So if we change that one, and the main command for starting the platform is to use the docker compose up and build command. Which will start the platform and build the containers. It can take a long time the first time you build, up to like 20 to 30 minutes. But it's using a cached copy here, so it's a bit faster. But now it's running the platform. And so once the platform started, you can just quickly check to see if it's running by going to the local address 27.1.1 8080, and you can open up. It gives you a list of some of the built-in activities from the Docker setup. And so just to get an idea of what the platform is like to use a student, they'll be presented with one of like this for an activity. So if we look at the EVL example, this is Epsilon. So where's an Epsilon example using EVL, Epsilon EVL. we have these validation constraints here. So if we then click the action button, it will run these for the UVL against the model and the meta model. So you run the action, and it generates a diagram with annotations on to show the EVL. And so that just demonstrates that the platform that is kind of running now and working to some degree. So what actually is running when you start the container there's different containers running. So you have the main platform, which is what we connected with, which is this 127.0.0.8080. And depending on the activity that's loaded, depends on what tools you can use. So in this case, it's the Epsilon tool example, so it's using the Epsilon tool, but there's some other tools available. So you have OCL and XText is another one. And so we'll look at adding an OCL example and also an XText example, creating activities for these. One thing, so this is all running locally on your local computer using all of these like local addresses. It's possible to deploy the platform itself to like cloud, for example, into like cloud functions. So using Google Cloud Functions to create some of the tool services. And in this case, addresses will change. So you have to use different addresses. But for running locally, you can just use these local addresses from the Docker container. Oh yeah, one other thing, I just think before we move on to creating the activity, there's also this token server configuration. And the main way to use the platform is through Git repositories. And so like for secure access to GitHub, this mediates the access like authentication. So you have to configure this. So that's the next thing we'll look at configuring. I look at configuring the token server. And that's detailed in the documentation. Where is that? In the setting up the platform here. And you won't go through all the details here because yeah, you generate some like client secret stuff, which we don't want to show during this demo, but the exact details are here of what to do. Effectively, it's creating a GitHub app, which you register under GitHub, and creating a configuration environment file, which is what I pre-created for this, which I'll put into like a directory to configure the token server. So if I copy that into if you can follow these steps and inside the environment file is just client ID and a client secret which is generated by GitHub application and a randomly generated encryption key which you need to use to provide, which can be generated using like the OpenSSL command. Yeah, the OpenSSL command here. And I'll restart the and I'll just restart the platform by doing Control-C, Command-C, and then restart. Okay, so I've restarted. So now this is the platform set up for the next part of creating the activity. So we've seen an Epsilon example. So now I'm going to create an OCL example. And so to to do that, we've got a GitHub repository, which I've pre-created. So this is just a normal GitHub private repository I've created, and the location is here. So I've checked out the GitHub repository, and that's where we can start creating our activity. And so for the OCL example activity, you might have a local project. So the project is something like this, where we have an OCL file with some constraints. So in this case, it's a library example from the OCL tutorial. We're verifying that the number of loans doesn't exceed the number of books. There's the metamodel file, and there's also the model instance. So if we run the validation, so to run OCL validation in Eclipse, you do something like OCL and validate, and it runs some OCL validation. So now to create the activity for a student to run this inside the education platform, firstly, you'll copy the files. So the files that are listed here, we'll copy them into just a directory. So if we create, actually, so we've copied these files which contain the contents of the project from Eclipse, and then next thing to do is to create an activity configuration file, which is what specifies the activity in the platform. So I go and so the activity configuration file is like a JSON or YAML configuration file. So if we call it and then we'll populate this with the configuration settings to actually create the activity. And so what we want the activity to look like. So as an example of what we're trying to create and what we're trying to achieve in the platform. So we've got the different panels for each of the different files we saw in the Eclipse example. So we've got the model, metamodel, and the OCL constraints, and a console panel for displaying the output. And so that's what we're going to put together in the configuration file to show the platform. Oh, can everyone see the screen? Because I think there's some comments in the.
Yeah, I think that's been fixed. I was very early on.
Okay, good. That's great. So
if it's possible to make it any bigger, or maybe not white on black, it's sort of the text is really borderline between being readable and not for me.
Okay, yeah, there you go.
That's much better, thank you.
Yeah. And so yeah, there's the top level object, which for the configuration file, and then there's multiple activities. So you have activities which you can have multiple activities inside an activity configuration. So this is an array style thing, and we'll have an activity so fields for the activity. Some of the basic fields is just an ID and a title. ID and title attributes. And so yeah, in this case, we just IDs calling it activity OCL, and the title, which will be displayed, is the model validation example in the thing. And next, another attribute you need is the icon, and this specifies the icon that's displayed in the menu, and this is specified by the tools, and there's some also built-in icon types. In this case, we're going to use the OCL icon. The next thing specifies the tool that you need to use. And this is the URL of the tool services. In this case, we need to use the OCL tool because we're using OCL as the main component. And so if we go back to the diagram of this, so we've got the OCL tool service, which is 8072. And so we've got 8072, and also because we're using FlexMI and EMF panels, we need to have the tools which provide those panels, and that's the Epsilon tool and EMF tool. So we also provide those using those tools. And so the tool configuration itself specifies the panel types available, and also the tool functions that you can use to create the activity. So if we go next thing to specify is the panels. So we've decided what tools we want to use. We've got, and you know what kind of panels we're trying to do on for our example. Again, you can have multiple panels. And panels can have, so the panels is like specify three main things. Again, you have an ID and a name. We're just going to call this panel OCL, and the title of the panel that's displayed will be OCL constraints. The other couple of things you need is a reference. And this is a reference to a panel type, and the panel types are given by the panel tool definition. So for the OCL one, if we go to, you can find out what tools are available by just navigating to this URL, or to the tools URL and seeing the configuration file. So navigate to the OCL tool. Oh. So the app is specified in YAML. It's it downloads it instead of viewing it. But okay, so we can view it by opening the file. And it's a similar structure to the JSON. So we've got panel OCL. So you got the different panel definitions, and yeah, okay, so and it's referencing the complete OCL panel, which is ID is complete OCL. Front end of the panel definitions. And then the last thing you need to specify for the panel is the type of the file that is actually displayed in that panel. So in this case, it's the OCL constraints file, and it references the file that's relative to the configuration file. So in this case, it's the OCL, and then in the OCL file. And so all the panels follow the same kind of pattern for their definition. So I just and these are the other panels, the Flex MI, the meta model, and then the console panel as well, which is a built-in panel type. Specifies each of these panels. Now we've defined each of these panels. And even though now they're defined, it doesn't specify how to lay them out. So you also need to specify the layout of the panels. This is done with the layout definition or attribute. And this is a multi-dimensional array of just the different panels, how they should be mapped. So it's done on a line-by-line basis. So the columns and rows, if I get the next. So the first row we want to have the model, then the OCL, and finally the console panel. And underneath that, we want to have the meta model. Underneath the panel model, we've got the model with the meta model underneath, then the two other panels there. It's a console, and so it maps directly onto the same that'll be displayed. And the final thing to define for an activity is the actions. So at the moment we've defined the panels, what's inside them, and their layout, and the tools we're using for each of the panels. But also you now need to specify what the action mapping, so when a button is pressed, what gets sent to the tool service functions. And that's done with the actions attribute. You can have multiple actions. So it's when you click on the run button, what tool function to call to process the request to get the output and where it goes to. So again, you can have multiple ones. So it's array of objects. So the source panel, where the action button is located, on the OCL panel, which is one where the OCL constraints displayed. If you look at here, it'll be the OCL constraints panel. So when that button is clicked, this also refers to the source button, which is button that's clicked. These are defined in the tool functions. So if we go to the tool configuration file, again, you can see it defines the functions, and there's an OCL function OCL, which has the parameters of meta model, and constraints. So the 3 parameters. And so you've got the 3 parameters where we're mapping the constraints input to the panel RCA contents, meta model to the panel meta model, and then the model to the contents of the panel model. And then finally, we just specify the output. And so the output is the panel console. The output's textual, so sending it to the output and display it in the panel console. And so that completes defining the activity file. Okay, yep. That completes defining the activity file. So now we can save this. And then push that to the Git repository. Okay, so we just pushed it to this Git repository. So now it's available here. And now we can access this activity within the platform itself. So if we to define the location of the URL, you can go to the click on the JSON file because it's the activity file. You can get the raw activity URL, and then you can copy the URL. And so then the way that you navigate to the activity is through a URL. So you just need to specify the URL to this activity that we just created. So activities, do that with the URL parameter activities, and then the URL of the configuration file. And also, because it's a private repository, have to set another parameter, which is allows it to use the token server to access the activity through. So if we go to now, we should be able to navigate to that. Okay, that worked that time. Yeah, I misspelled activities in activities. So now, yeah, it's asked to log in. So if I sign in with GitHub, I've pre-logged in with my GitHub credentials, so it would automatically just log me in, but otherwise it'd prompt you to say, please log in. And that's where the token server comes in to say and authenticate you with GitHub and yeah, access the files through the token server. So now it's loaded the files from that private repository. And we can see we've got using the OCL examples, so we've got, and this is what we saw in the Eclipse. So we've got the model, the meta model, and the OCL constraints. So if we run the validation, here run some validation, and it says there's an error because there's an extra library block in the library than there are loans. So if we delete one of these loans, complete validates successfully. So that's the OCR example. We can also save as well because we have the token server set up. If we save this now, it will save the model file to the repository. So now the error's fixed in this. So you got the you can see it's saved. Anyway, so we deleted that and it's saved it in as a commit to the repository. So that's good, but now we might want to also have language workbench examples. So say you want to add to this, we've done something simple, and we want to add another activity to our file. So we can just go on, carry on adding to the activity creation file. We started to create. So the example we're going to look at is actually adding language workbench example. So this is with xtext, and actually I guess we'll let you show it in the clip. So the example we've got we've got an xtext project here, which is a simple turtle kind of language robot example for moving a robot, like an educational robot. So if we create this and there's an xtext grammar, okay, it wasn't clicking, but now it is, yeah. So if we go to source, oops. So we have an xtext grammar, and so if I run this example, we'd like to move turn statements. So if I now run this example, okay, just being slow. Okay. Yeah, it creates an instance, another Eclipse instance with the language, and yeah, you've got this auto completion and general xtext. Things like that, so that xtext thing. So we want to put this activity into the education platform. So the aim is to have something like this where you have the xtext grammar displayed, and when you click the button, it generates another xtext editor instance that you can then use your language in and test out the So we go back and modify our project file that we started earlier. So we go to that and then so we've already got one activity, so we're going to add another activity. So it's just a case of adding another object. And we've got some of the basic things from before. So one ID, which is the ID this time, just activity XX turtles, and then also a title, which is XX language workbench, and then icon, which is X text icon to use for the menu. And then again, this time we're going to use just the X text tool, so a different tool from before. But again, the URL from the Docker configuration. So then we want to define our panels. In this case, it's just going to be a XX panel and a console panel, just displaying the response. So if I go so yeah, for the panel, for the XX panel, it's just the basic, yeah, given ID, the title as well, and then the reference is referencing the XX grammar panel specified in the tool configuration. So you can look at this tool configuration. This time it's an example of the JSON format tool configuration file. So again, you can use JSON or YAML. So the panel definitions, so the XX grammar. So we're using this panel definition. Which has the action button and help button available to specify the file. Yeah, we need to actually copy the project files as the important point to do. So if I get those project files, so yeah, we're copying these project files here into our activity. Of the parent directory with all these sub-projects in, and in the turtles, you have the X text grammar. Yeah, it's quite nested down, but why you've got a long path name here, but yeah, it refers to the grammar file. It's in the X text project, and additionally, there's also to specify the output location for the editor. We also add the editor panel and editor activity. And so that's all in our second activity. We'll refer to those in a minute. And that's where the panel will be, the editor will be displayed for the generated editor instance. And so define. So we've also got a console panel. Okay, yeah, and so we'll define the panel that outputs where to output this to. So another editor activity. So the editor that's displayed hidden here, but it will appear here once it's built. So we need to define that as like an activity. I'll follow the same pattern as before. So we refer, so we create a separate activity, which is the titles editor activity. We've given it a layout and some other panels so the next text editor rather than next text grammar, and so we refer to this in here. So we refer editor panel, which is the panel titles, and the activity titles editor, which is the activity titles editor here. And yeah, panel titles is here. And so going back to the XX grammar activity, we need to add the layout. So we add a layout. A simple layout, just the panel X text, which is this panel above the console panel, which is the console below it. And then finally the action. So is when you press a build button or the green arrow button, it should build the X text editor instance. So we need to add the actions. This is one action, but you could have multiple actions if you have multiple panels of actions. And oops. The source is the X text panel, and the action button that's on there, that panel, and that's specified by the tool configuration file in here. So the button, so it's got the action button. Yeah. So then the parameters to this tool function. So you've got function X text, and it's got these different parameters like a language name, base name, extension, grammar, and project files. And some of these are so the grammar file is the file, but some of these are the properties of the X text project. They have to be specified now. So if I copy those parameters in. So some of these are just textual ones based on the like X text project properties. But when it refers to a panel, the contents of the panel are substituted. So in this case, the panel X text panel will be used for the grammar, which is this one here. And that's the grammar file from the project file in here. And finally, we need to specify an output. So we'll specify the console panel output. And that should be everything for that definition now. So defined we've added to our original activity. So it's going to have the OCL activity that we had originally with this new xtext title activity. And because we're doing a language workbench, which has an extra step, you need to specify the editor in a separate activity as well. So this activity has two parts to it, which we'll see when we run it. So now we've created that. And so if we go to xtext. Okay, that's weird.
Do you need to pull this change that you've saved?
Yeah, that's right. Yeah, good point. Thank you. I forgot about it because we there's a platform committed a change in between. I'm going to move the files, all of the files out. Let's put the Git file back in.
I think this is just your Git not being configured correctly, right?
To do what, sorry?
It's just your Git not being configured correctly. It just doesn't know how to merge in the changes.
Yeah. I mean,
you just have to. If you can just tell it to do the git config full rebase false thing, and it should do it.
So just git rebase full.
Yeah, so it gives you that as a suggestion. Even that's the first suggestion.
This one. Yeah, I mean, I can just try. I run it. I can run it locally. Potentially. Go back. So yeah, one option is you can run files locally as well and through the Docker. It's not the recommended way of doing it, but it can help if there's if you have a problem. So I now go to 82, I think. So I can access activity locally rather than go through Git. So there's just some issue with not filling in the change properly through the Git. So then if we go to the OCLX text, which is our file which created activity xxturtles, so this is the one we've just been creating. I use that. Specify the location of this file, and then it's not private anymore because it's just running it locally, so you can just specify the file directly without the private true. So if we run that, I think it's probably an error with the file. If I open it up in this editor. Missed something out. Is the file? There's the runtime Eclipse application file I forgot to put over, but I didn't think. Oh, okay, it does use that. So for the panel, the generator panel is probably looking for this file, which I forgot to copy. So if I put this folder in there, which is a runtime Eclipse application folder, which just contains a test turtles file, that will.
So is this anywhere, somewhere, like a useful error message that would tell you that was the problem, or did you just have to know?
Yeah. At the moment, there's not particularly useful error messages. The way to do it is you can look into the debug log in here. It might give you something, but it's something that we're adding as the next phase of work is high priority to get nice.
Yeah, good. I'm glad to hear it. Thanks.
Yeah, it's it's not good when, not handy when things don't work. Okay, I'm not sure why it's complaining now. It should be the right files and everything. Have a quick look at the text tool. So it's going to load that configuration file, but should be fine. Yeah, I can run the local demo of the similar activity, but just not the one we created just now, unfortunately. Yeah. So we run the exec language workbench example from here. So this is what we should end up with and displayed. So you got the exec language workbench with the grammar file. And then when we click run, it starts to build the editor. So you can see it's building the editor down there, and it takes a bit of time, but because it has to send it out and create the project, build the editor, and then create an editor instance, and then make that available to the platform. So that's what he's doing now. And okay, so the building's complete, and then it's the editor has now appeared here. So we go to the titles editor, it loads the editor, and yeah, it's an auto completion thing for the text example. So yeah, you have. Yeah, it shows you some validation as well. So that shows that the language workbench kind of example. And so for some integrations, so one way it's envisaged is with GitHub Classroom. So you can use GitHub Classroom to run to integrate the education platform with that. Cool. And that is a similar setup to the so you use this activity, you can use it. So yeah, for GitHub Classroom. You can create classrooms which you can have multiple. It creates, you set up for like a student, for different students, and it creates repositories per student, so it automatically initializes them, and so that, yeah, the goal is to integrate it with this, and so this demo activity, you can make to do that, you need to use it as a template. So you just set this repository to a template in settings, make it a template, and then you go to the GitHub Classroom and then create a new activity based on it. And so you do this from an organization, and as an educator, you can sign up and get free access to it. A list of students, and you can then use the repository we created. And that will initialize the project with or repository for each of the students with different, there's other things you can do like assessments and stuff. So you can access this, and then it creates a repository with the copy of the files that were created with the activity and things on. And then you can access this with the education platform itself. So that's kind of the envisaged way to use it. I think that's most things. And yeah, so in the future, we want to like gather more experience from actually using it, the platform, as well as add additional tools, create some open educational resources, configure file editors and usability things. So yeah, validators to make the creation of the configuration files easier, because at the moment it's a bit of a manual process. And finally, investigating adding graphical languages. And I guess as we have some time, we've got some time for questions. So if there's any questions or anything that would like clarifications on, then yeah.